This week, we're going to go over sections 2.4, 2.5, and 2.6. To prepare us for these sections, let's do a few problems from each section. So for section 2.4, we're going to learn about graphing quadratic equations. So a quadratic equation looks like this. So we'll have f of x or g of x or something like that on the left-hand side. And then we'll have is equal to a number times x squared plus a number times x plus a number times c. Here, a cannot be 0, and a, b, and c are real numbers. We're going to want to graph this, so we're going to need to know how to find the vertex. I'm going to teach you how to find the vertex of something like this. So the vertex is the minimum or maximum of the parabola. So remember that a parabola is just another word for a quadratic. So if we have a parabola that looks like this, where it's pointing up, this point, the minimum, is the vertex. If the parabola is pointing down, the maximum here is the vertex. So it's either a minimum or a maximum depending on the way the parabola is pointing. And the way we can determine if it's a maximum or minimum actually depends on this letter here, A. So if A is greater than 0, then your parabola is pointing upwards. And if A is less than 0, it's going to be pointing downwards. So let's write that down. The number A determines if your parabola is pointing upwards or downwards. So if A is greater than 0, you're pointing upwards, which also means that your vertex is a minimum. Now, if A is less than 0, you're pointing downwards. Like that. And this one's upwards. So you're pointing downwards, so your vertex is a maximum. Now, if A is equal to 0, then you don't have a quadratic. And this won't happen in these sections because in the very beginning, remember I defined a quadratic as this first number here is not equal to 0. So we won't actually have to worry about this case. So we can really just cross it out. The only cases we're going to worry about is this one and this one. Now to find the vertex, should put more space here. So to find the vertex of something that looks like f of x is equal to ax squared plus bx plus c, what you're going to do is the vertex is going to be given by, for the x coordinate, you're going to take the opposite of b and divide it by 2a. And then for the y coordinate, you're just going to plug in whatever you get here into this function. So you're going to evaluate the function at negative b over 2a. We're going to do some examples of this. So in your homework, you're going to see problems that take this form. So your quadratic will look something like this. For example, f of x is equal to x squared plus 3x minus 7. This function here is in this form where a is 1, b is 3, and c is negative 7. So to find the vertex, you would take the negative of this, divide by 2 times 1, which is the a here. And then whatever that number is, you're going to plug it into the function and you're going to get the y value of the vertex. And then we're also going to be able to just look at the coefficient in front of the x squared term. And the number in front of the x squared term will tell you if you're pointing upwards or downwards. And here, for this particular case, the a is 1, which is greater than 0, and you're going to be pointing upwards. So that's something we're going to do. We're going to do some examples of that. But there's another type of quadratic you might see. So the form of the quadratic, you'll see it in 2 different ways. So if you have a quadratic function that looks like this. So here, if you FOIL this out, let me give you an example, just so you know what I'm talking about. So for example, let's say you have f of x is equal to 2x minus 4 squared plus 3. Now you could FOIL this, and what you're going to do is you're going to get something that looks like this form if you FOIL it out. So if you expand this, let me show you just so we're clear. This is 2 times x minus 4 times x minus 4 plus 3, which is 2 times, I FOIL this, I get x squared minus 8x plus 16 plus 3. And then distribute this 2. And you can see that I can put it back into that general form we saw. So now it's in that form ax squared plus bx plus c. But what I want to tell you is if you have it in this form, you actually don't have to do all of this work to get it back to the general form. There's a really easy way to find the vertex. So if I give you a problem that looks like this, the vertex is going to be h comma k. And you need to be careful here. The h, you see how you have a negative here? But I'm taking the positive. So you're always going to take the opposite of what you see here, but you're going to keep the sign of this one. So if I had x minus 4 minus 3, for example, so let's say the function was f of x, let's put a 3 here, x minus 4 squared, and then let's put a minus 2 out on this side. Then your vertex is going to be 4 comma negative 2. So I take the opposite of this sign, which is a positive 4, and then I keep the sign of this one, which is a negative 2. If I made this a plus 4, then you'd have to make this a negative 4. So we're going to do some examples of this in just a second. I also want to mention that this number a here, that's the same a in the general form. So remember that we had this form f of x is equal to ax squared plus bx plus c. And if we, FOIL this out like I mentioned earlier, then this number on the outside is that same number here. And so if this number is a positive number on the outside, then that tells you your parabola is pointing upwards. And if it's a negative number, it's pointing downwards. So let's do some problems. Let's find the vertex of the following quadratics and determine if the graph opens up or down. So here's our first problem. F of x is 2 times x minus 7 squared plus 3. Okay, again, I mentioned that you can FOIL this out, but you don't have to. It's really easy when a function's in this kind of form, which is in the form f of x is equal to a number times x minus a number plus a number on the outside. You can see that this is our a, this is our h, and this is our k in this form. So when you have it in this form, you can quickly see what the vertex is and if you're pointing up or down. So our vertex is just 7, 3. So the opposite of what you see, which is -7, take the opposite, and then keep the sign of this one. And we're pointing upwards. And that's because A is equal to 2, and 2 is greater than 0. So our vertex is at 7, 3. Now you don't have to graph it. It didn't say graph this, but I want to give you an idea of what we're doing here. So we can go over 7, 1, 2, 3, 4, 5, 6, 7, go up 3, and put a dot here. And because we're pointing upwards, now I'm going to sketch the graph. So it's not going to be perfect, but for this x value, you can put a line right here. Because this line is called an axis of symmetry at x is equal to 7, because remember that a parabola is symmetrical. So whatever is on this side of this x value, x is 7, you're going to have the identical copy over here. So this is the basic shape of the graph. It's going to have a vertex, which is a minimum because we're pointing upwards, and we're going up like this. You can see that here. Let's try another one. So here again, we're in that form, f of x is equal to a number, x minus h squared plus k. We need to figure out all the little letters here. So a is -2/7, which notice that this is less than 0, which tells us we're pointing downwards. So our parabola is going to look like this. And then our vertex is h, k. Now the number here is a +4, which is the same thing as x minus a -4, right? So remember, we have a minus. In this formula, we have a minus, so we need the opposite here. So instead of 4, we go with -4. So our vertex is -4, and then we keep the sign of this one, which is a 1. So it's always the opposite of in here, and you keep the same sign. So this is our vertex. Again, we could give a little sketch of this graph. So this is the x value, so we go over 4 and up 1. So that's our vertex. We're pointing down, so the graph is going to look something like this. And it's going to be symmetrical with respect to this x value here. So whatever's over here, you're going to have the identical copy over here. Okay, now I've switched to the other form, which is f of x is equal to ax squared plus bx plus c. Again, we want to find the vertex and determine if the graph is pointing up or down. Let's write out what a, b, and c are. So a is the number in front of the x squared, which is a 1, b is 3, and c is -4. Since a is greater than 0, we're pointing upwards. The vertex is given by -b/2a, plug in -b/2a into our function. So this part is simple. You might get a little confused on this piece. So let's do both. So we take b, so x, and then remember this is the x value and this is the y value, or in other words, you can put this as h and this is k. So x is going to be -3, the opposite of b, over 2 times 1. So x is equal to -3/2, and let's leave it like that. Now we're going to plug this value, -3/2, into our function, and here's our function right here. So wherever I see an x, I'm going to plug in -3/2. So I have -3/2 squared plus 3 times -3/2 minus 4. Square this is 9/4. This becomes a -9/2. And then this is -4. Let's simplify it a little bit. I want to get the common denominator here. So I'm going to multiply this top and the bottom by 2. And I get 9 over 4 minus 18 over 4 minus 4. This becomes 9 over 4. Sorry, negative 9 over 4. Subtract 4. So I'm canceling these two by making it a negative 9 over 4. And then I want to combine these two. Now, 4 is the same thing as 4 over 1. So I need to make that denominator 4. So what I'm going to get is negative 9 over 4, subtract 16 over 4, which is negative 25, I believe, over 4. Okay, so this is the y value, or the k value. So this is what you're going to plug in for here. So our vertex is negative 3 over 2, comma, negative 25 over 4. Now this wouldn't be something fun to graph because we have fractions. We could try to identify the graph. Notice that both of these are negative numbers. So if I wanted to graph this, well, I can tell I'm going to be in quadrant 3 because the x's are negative and the y's negative. This is negative 1/2. So we're about, sorry, negative 1.5. So like right here. And then this is, well, let's think about this. 5 times 4 is 20. 6 times 4. So it's a little bit bigger than negative 6. So somewhere down here. So we have a point here. It's at negative 1/2 and negative 6.25. And then we said that A, the number in the front was 1. So we're pointing upwards. So the parabola is going to look something like this. Now it might be skinnier or even fatter than this, but the idea here is right here at x is equal to negative 1.5. You're going to be pointing upwards and your graph is going to be symmetrical. So whatever's here is over here. Let's try another one. So here I give you the function f of x is negative 2x squared plus 14x minus 3. Let's write the general form. Let's write what a, b, and c are. So a is negative 2, b is 14, and c is negative 3. A is less than 0, which tells me we're pointing downwards. Okay, and our vertex is given by negative b over 2a, and plug in negative b over 2a. So negative b over 2a is equal to negative 14 over 2 times this negative 2, which is negative 14 over negative 4, which I can simplify to 7 over 2. A negative over a negative is a positive. So this is the value that goes here. This is your h value for the vertex. To find your k value, we're going to plug in 7 over 2 into our function, which is negative 2x squared. So let me copy this, put it here. So wherever I see an x, I'm going to plug in 7 over 2. I'm going to square that. Then I have an x here, so I'm going to plug in 7 over 2. And then I want to simplify it. So I get negative 2. This will be 49 over 4. Remember, you got to square the top and the bottom. Plus, I might need a calculator for that. So let's pull out a calculator. So 14 times 7 is 98. Actually, what we can do, we can simplify this. No, let's just keep it. So 14 times 7 is 98. So it's 98 over 2, subtract 3. And I want to simplify a little bit. So I have a negative 2 and a 4. That'll go in negative 2 times. So I have 49 over 2, and I put the negative out in the front here. plus 98 over 2 minus 3. So let's put in the calculator 98 minus 49, which is 49. So I get 49 over 2, and I want to subtract 3, but I need them to have the same denominator, so let's make that a 6 over 2. And then 49 minus 6 is 43 over 2. So that's going to be our vertex. 7/2, so let me put that here. Our vertex is 7 over 2, comma, 43 over 2. So that's all the problems I want to do for this section. Now, in section 2.4, in pre-calculus, we're actually going to graph these. We're going to use transformations. And we're going to do a lot more with this. But this is a good starting point for you to understand section 2.4. Okay, section 2.5 is solving inequalities. So before we saw something like f of x is equal to x squared plus 2x minus 1. And I asked you to find the vertex and to graph it, or have an idea, sketch the graph, and determine if it's pointing upwards or downwards. Now what I'm going to do is I'm going to take something like this as x squared plus 2x minus 1, and I am going to put it less than or greater than or equal to a number like 0. And some things you'll be able to factor, and I'm going to teach you how to determine the x values that satisfy such an inequality. Okay, so you can see on the left-hand side of this inequality, I have x plus 1 times x minus 1. If we FOILed this out, you would get x squared, then you get a negative x and an x and a minus 1. You can see that this is the difference of squares. So what we have here is a quadratic, and it is greater than or equal to 0. So for this kind of problem, what we're going to do is we're going to graph this thing. Now we know that the quadratic breaks into this, x plus 1, x minus 1. So what I'm going to do, I'm going to ignore this for right now. So just ignore this and pretend like we have this function, f of x is equal to x squared minus 1. And we know it factors into x plus 1, x minus 1. Now if we wanted to find the x-intercepts, what would we do? Well, to find the x-intercepts, you set y equal to 0. So you get 0 is equal to x plus 1 times x minus 1. And you get that x is equal to negative 1 or 1, just by setting both of these equal to 0. Let's plot these points. So we have negative 1, 0, and 1, 0. Now remember, we have a quadratic, and a quadratic looks like this, or it looks like this, right? So which one do we have? Notice that we have 2 points here, and the only time we're going to have 2 points side by side, let me rephrase that. The only time we don't have 2 points side by side is when we're at the vertex. Notice that for any point you have over here on the left side of the graph, you have it over here on the right side. And for this one pointing down, anytime you have a point here, you're going to have it on the other side. If it's way up here, it's going to be way up here as well. So you can see that they're right beside each other. So we either have a graph like this, or we have a graph like this, pointing upwards. But which one do we have? Well, to figure that out, we just need to look and see what the number is in front of the x squared term. Because this is in the general form. You see we have x squared minus 1. This is the same thing as 1x squared plus 0x's minus a 1. So the a here is 1. So for this particular problem, a is 1, which means we're pointing upwards, right? And looking here, if you don't want to FOIL this out and put it back into this general form, you can just look in front of the x squared terms. So notice I have a 1 here and a 1 here. And if I multiply them together, I'm going to end up with an x squared. And that's going to be a positive 1, which means we're pointing up. As long as I don't have any negatives like on the outside or a negative here, we just need to multiply the x terms. So whatever we get with the x squared term, that's going to determine if our graph is pointing up or down. Since we're pointing up, now these are symmetric and they're both a unit apart. We could also find the vertex if we wanted to, but I know that this graph is symmetric. So somewhere along this line, I'm going to have a vertex, and it really doesn't matter where you put the vertex. This is a sketch. All I need to know is if the vertex is above the 0, y is equal to 0, or below. And because it's pointing upwards, you know it's going to be below. Okay, so the graph is going to look something like this. This vertex may be further down. It may be closer to the 0, but it's going to be like this. And it's not going to be right here because when you have a vertex right here, you'd only have 1 point, and you can see we have 2 points. So our parabola is pointing upwards, okay? Now, why did we do all of this work? We're going to look at our quadratic, this graph that we made, and we want to find all of the x values. So remember, x's go from left and right, and we want to find all the x values that are greater than or equal to 0 when we plug them in. So when we plug them into our function, we get a number that's greater than or equal to 0. So looking at this graph, if I plug in, let's say x is equal to 0 into it, my y value is down here at the vertex, which is below 0. Remember, this is the 0 line. So what I'm asking here is whatever x value you choose, notice that anything from, remember, this is -1, comma 0, this point here, and this point is 1, 0. We found these x intercepts. And you notice that anything you plug in between -1 and 0 will give you something that's below this blue line. I want to find everything that gives you something above the blue line. So if you choose anything bigger than -1, let's say you go with -2, then this point will be right here on the graph, which is above this blue line. And in fact, anything from -1 to infinity, negative infinity, will be on above this blue line. And anything from 1 to positive infinity will be above this blue line. So the values of x that are greater than, the values of x that when you plug them into the function, you get something that's greater than or equal to 0, would be from negative infinity to -1. Let's talk about if we need a bracket or a parenthesis there. And also from 1 to infinity. Now, because we can be equal to 0, that means we can be above or on the line. The only time we're on the line is when x is equal to -1. So we put a bracket here because when we equal -1, we are on the blue line and we're looking for things that could be on the blue line as well as above the blue line. And then when we're equal to 1, we're on the blue line, so we can include that. So it's anything from -infinity to -1 and from 1 to infinity that will be above this blue line or on the blue line. Now anything from -1 to 1 will put us below the blue line. So if I switch this to this sign, so instead of having this sign here, I made it a less than sign, then you would say the solution would be from -1 to 1 with parentheses because this is a less than sign, not a less than or equal to sign. Okay, we're going to do another one so we can get some practice with this. Okay, here's my second problem. I have 2x minus 1 times x plus 12, and I want that to be greater than 0. Couple things I'm going to do. First I'm going to FOIL this out. You don't have to FOIL this out to solve this problem, but I want you to see that it is a quadratic. In fact, anything in this homework section is going to be a quadratic, which means it's going to be a parabola, and we can sketch the graph. So let me multiply this out. 2x minus 1 times x plus 12. That is 2x squared plus 24x minus x minus 12. Let's simplify this. And I'm going to call this side of the inequality, I'm going to call it a function f of x. A couple things to notice. I have a 2. This is my a value, okay? That means my graph is pointing upwards because it's a positive 2. I could also find the vertex if I really wanted to. I don't need to find the vertex because I have it in factored form, which will give me the X intercepts. And having the X intercepts, because there's 2 of them, halfway between those X intercepts will lie the vertex. It'll either be above the line y is equal to 0 or below it. So let's try to sketch this. So let's talk about the X intercepts. That's when we set this function that I'm calling f of x, we set it equal to 0, okay? So if I set this thing equal to 0, we have 2x minus 1, x plus 12 is equal to 0. I get x is equal to 1/2, setting this piece equal to 0, and x is equal to negative 12. So let's graph this. 1/2, where is it? Let's say I want to do this kind of to scale because negative 12 is a really, 12 is a big number, so let's try to make this a little bit better. I'm going to have to put a lot of line on this side. Okay, so let's say this is 1, and I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, way out here. In fact, I want to see if I can move this. Okay, that didn't really work, so let me try again. Put it out here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we said that x is equal to negative 12 is one of the x-intercepts to this function here, because this is the factored form. And so to find the x-intercepts, we just set this equal to 0 and we can factor it. But since we already know the factored form, I just wrote that here. And negative 12, 0 is one of the x-intercepts. The other one is 1/2. So if this is 1, this is a half. So it's 1/2, 0. So the graph goes through these 2 points. We know the graph is a parabola, so it's symmetric. We also know that this graph is pointing upwards because a is not equal to 1, it's equal to 2, which is a number that's bigger than 0, so we're pointing upwards. So that tells me that my vertex is halfway between these 2 points and below the line x is equal to 0 because we're pointing upwards. I don't know really where exactly, but it needs to be halfway, and we just need to sketch this graph because all I really need to know is what the graph kind of looks like. I don't need it to be perfect. I just need an idea. So something like that. That's what the parabola looks like. And that's going to help me figure out the solution to this inequality. So let me erase this because I don't want it to look so messy. Okay, now let's look at the inequality. So here we have a function and we want to set it greater than 0. So let's find the line y is equal to 0, which is always going to be this axis. And we want all the values of x that when we plug them into the function, which is this parabola, we're sitting above that line. Okay, so you can see that the red line is above this when we're going out towards negative infinity. Anything over here, if we plot it on this parabola, is going to be above this black line. And anything past 1/2, if we plot it on the graph, if we plug the x value into the function and plot it on the graph, then we would be above that black line. So the solution to this is anything less than -12. And I'm going to put a parentheses here. I'll explain that in just a minute. And then anything bigger than 1/2. So why are we putting parentheses here? And that's because of this sign. If I said equal to, so if I said greater than or equal to, then you would put brackets here. If I just say greater than, that means we cannot equal 0, which means we cannot be on this line. And because we cannot be on this line, we don't include the points that are on the line, which is when x is -12 and x is 1/2. So that's why we have parentheses here. Let's look back at the other one. We had an equal sign and we put brackets here. I think I have another one. This time I'm going to switch the line to, switch the inequality to less than or equal to. So let's see if we can do this one. In fact, maybe pause the video and try to solve this on your own, and then come back to the video and make sure you get the right answer. Okay, I'm going to FOIL this out. So I get a function. The function is going to be x squared. I'd have a -7x plus 5x. So I get a -2x and then a -35. And I'm going to try to sketch this graph. Oops, it's not a very good line here. Okay, couple things to notice. A, the number in the front, well, I just multiplied an x with an x, a is equal to 1, which is greater than 0, which tells me my graph is pointing upwards. Also, my x-intercepts are 7, 0, and -5, 0. Always the opposite of what we have in here, because if we set them equal to 0, we move the 7 to the other side and the 5 to the other side. So let's plot these 2 points. So we have something at 7, 0, and we have something at -5. It's not quite as far out, so let's go about right here. -5, 0. So we know 2 points that it's going through, halfway between these two. Now, because this is not -7, it's not going to be right on this axis here. It's going to be a little bit to the right. Let's say right here. The vertex is going to be below these 2 points. The reason for that is because of the a value. It is positive, which means we're going to have a minimum. And then we're going to just sketch a graph. It doesn't have to be perfect. You just want an idea of what the graph looks like. Okay, now we can focus on the inequality. So I want to know what x values, when you plug them into here, which means the function's values, what values are less than or equal to 0. So if this black line is 0, notice that I'm going to be below or sitting on that black line when I'm between -5 all the way to 7. So the solution here is from -5 to 7. So anything from -5 to 7, when you plug them into your function, you're going to be below this black line. And you can put brackets on -5 and 7 because we have this equal sign here. So we can also equal 0. I wouldn't do one more. I think this is the last one. Yeah, but I want to switch one of these signs. So let's put a negative right here. Okay. So for number 4, I want to determine all the values for which x when I plug it into this quadratic, I get something less than 0. So I have negative 1/3 x minus 2 times x minus 8. Okay, so like I said, we don't have to FOIL it out. You can if you want to. I just really need to know what a is. So the number that's going to be in front of the x squared term. So it's not equal to 1, but what is it? Well, when we FOIL this out, we have a negative 1/3 x times a 1 in the front here. So it's going to be negative 1/3 because you would have a negative 1/3 x squared. So that's always the a. This is less than 0, and that's the reason I put this negative here. I wanted to see something that was less than 0, which tells me that I'm going to be pointing down. Let's write our X intercepts. They are, well, we're going to have to plug each one of these pieces equal to 0. So we get x is 8, and negative 1/3 x is equal to 2. So x is going to be negative 6. Multiply by 3 and then divide by this negative 1. So we have 6 and 8. So let's just give a little sketch of this. So negative 6 is somewhere around here. 8 is a little bit further. And this graph is pointing down, which tells me the vertex, which is halfway, the x value is halfway between negative 6 and 8, so somewhere around here, is going to be above the line y is equal to 0 because we need this function to point downwards. So we're going to look something like this. Okay, it doesn't have to be perfect. I just want the idea of what this graph looks like. Okay, so we want to find all of the x values that when we plug them into this function, we are less than 0. So looking at this graph, think about the x values. When you plug them in, if you plug anything between negative 6 and 8, what's going to happen? Let's say you plug in negative 2. You're going to be up here, which is above this line. So that is not one of the x values we need. What we need is anything that's to the left of negative 6. Like if we plug in negative 8, plug that in on the graph, this graph is going to go on forever, it's going to be below this black line. So we can see that the solution is anything from negative infinity to negative 6. But because I'm not saying equal to, I'm saying less than 0, we're not going to include negative 6 because that sits on the black line. So union, anything bigger than 8. So 8 to infinity. Okay, so that is the major idea for section 2.5. You're going to do more problems. Most of the problems won't be factored like this for you. I went ahead and factored it so you can look at the heart of what we're doing with inequalities, but you may have to factor it. I'll give you the function like I did before. Let's see, maybe I still have it written down here somewhere. You see how I've put it in this form, x squared minus 1 for number 1? You'd have to factor into this form and then do all of this. So it's the same thing, just like one extra step. Okay, for section 2.6, what you're going to see is word problems, and the word problems will want you to write an equation of a quadratic. So instead of giving you the quadratic and asking you things about it, I'm going to give you a bunch of words, and you're going to have to interpret the words into a function. And then they'll probably ask you for a vertex or the intercepts of the quadratic. But right now, all I want to do is just set up the equation. So we have, for number 1, the right triangle given below has a perimeter of 12. Find the equation for the area of the triangle in terms of the variable x. Okay, so let's see if we can interpret this. We know the perimeter is 12. I didn't spell that right. Perimeter. The perimeter is adding up all the sides. So let's say y plus x plus 5x is equal to 12. Or in other words, y plus 6x, because I can add these together, that's equal to 12. Now I want to find the equation for the area of the triangle, but I only want it in terms of the variable x, so I don't want any y's in my equation. So let's just write what the equation of a triangle is, right? Area is 1/2 base times height. And the height is always perpendicular to the base. And that one's really nice for a right triangle because I already know that these two sides are perpendicular. So the area is 1/2. Well, the base here is x, and the height is y. Now, I'm almost done. The issue I have here is that I want to find the equation for the area just in terms of x. I need to get rid of this y. And the way we're going to do that is we're going to use this perimeter formula right here. And we're going to solve for y. And when you solve for y, you just plug that into the area equation. So if you solve for y, you get y is equal to 12 minus 6x. And then you just plug that in here. So the area is 1/2 x times 12 minus 6x. And if you want, you can write this as in functional notation. We can say a of x, which means the area. And your homework might ask you to actually simplify, I guess they call it simplifying this, but they want you to distribute. And you'll get 6x minus 3x squared. If you FOIL this out, notice that you get a negative 3x squared. And then if you put this piece here, 6x, I just changed the order because usually with quadratics, we put the part with the x squared in the front. And you can see that this is a quadratic. So these problems you're going to have in section 2.6, they're going to be quadratics. Okay, let's see another problem. This one says, Michael wants to construct a rectangle with a perimeter of 100 units. Find an equation for the area of the rectangle in terms of only the variable x. So this is very similar to the last problem we did, except for we're using a rectangle. So we have a rectangle, and we know the perimeter is 100. And we want to find an equation for the area. Well, let's label two of the sides. Let's call this side x and this side y. And it doesn't really matter which sides you call what. Well, we know area is x times y. That's the equation for a rectangle. It's always length times width. But I only want the variable x. So to get rid of the variable y, I have to use the fact that the perimeter is 100. So let's write all of the sides out. Notice the perimeter is going to be x plus y plus x plus y, which is 2x plus 2y. That is going to be equal to 100. And from that perimeter equation, you can solve for y. So if you move the 2x to the other side and divide by 2, you get 50 minus x, because I have 100 minus 2x, and then divide by 2, that halves everything. And from there, you can plug that y into your area equation. So then the area of x, if you FOIL this out, is negative x squared plus 50x. Something that your homework might ask you to do is find the maximum of the function, which remember what maximum is the highest most point for this function. And looking at the function, you can tell it's a quadratic. And you can tell that the quadratic is pointing downwards because the number in front of the x squared is negative. Because it's pointing downwards, you can find the maximum just by finding the vertex. So we're going to do one more problem where we're just setting up an equation for area. And it's almost identical to the last problem. There's just one little difference. So let's read it. It says, Jacob wants to fence in a rectangular piece of land next to a street. I always suggest drawing a picture to help you with this. So you have a rectangular piece of land and it's next to a street. He has 2,000 yards of fencing and he does not want to fence in the side facing the street. So let's say here's the street here. So he's going to fence in this piece, and this piece, but not here. And he has 2,000 yards of fencing. Find an equation for the area of the land in terms of only the variable x. Again, we want to come up with an equation that has two variables and then get rid of one. So since this is a rectangular piece of land, we're going to say x and y, just like we did before. And in fact, this is also x, and this side here is y, but I'm not going to write it. And the reason for that is I don't need it when I figure out the perimeter. So if he has 2,000 yards of fencing, well, what we're going to do with the fencing is we're going to lay the fencing here, and then here, and then here, which is just the outside, so it's the perimeter without this piece. So we're going to go an x plus a y plus an x. These lengths, that's going to equal 2,000. So in other words, 2x plus y is 2,000. And we can solve for y. Y is equal to 2,000 minus 2x. We want to find an equation for the area of the land. So area is all of this stuff here. That's your area. And area is always x times y. But now we can use this y. We're going to plug that into our area equation. We get x times 2,000 minus 2x. And now we can write a really nice equation for area. It's just negative 2x squared plus 2,000x. I distributed and then I switched things around. So now we have an equation for the area of the land in terms of only the variable x. Your homework's going to ask you for similar things, to write things just in terms of this one variable. And this is what I want. I want you to get rid of the other variable and just have an equation involving x.